In this video, we're going to take a look at what happens when we change the how you do it number in our base song. As you might think about, everything up until now has been how do you do it 10. Well, what happens if we pick another number than 10? It's certainly possible. So as a part of this, I'm going to be working with you to develop a little joke. And it's not the funniest joke in the world, unfortunately, although I will confess I quite like it. But if you understand the punchline, what it tells you is you will also understand something about the nature of base and how you can have alternate bases to generate and develop number representations. In the joke, we're going to make use of our song and its basic ideas, which is first, that the how you do it represents the base. The number of times we sing the song represents the exponent. And the place value is the resulting number that results of taking that base and performing the number of iterations as indicated by the exponent. So having said that, we will go ahead and we'll tell the little joke here, and then we'll see if we can figure out how it works. Being a math person is I can choose when to celebrate two of my favorite holidays. That's Halloween and Christmas. And it's wonderful because I can celebrate either one on the day I choose. I could celebrate Halloween on Christmas, or I could celebrate Christmas on Halloween. Isn't that great? That is the joke.
We now have everything we need to really understand our joke, and I do have to apologize. It's not the funniest joke, but again, if you understand it, you will understand some important concepts about base. First of all, by way of reminder, we'll remember that Christmas is taking place on December 25th. That happens every year, the same day, so that's an easy one to keep track of. The other holiday mentioned in our joke is Halloween. And of course, Halloween takes place on October 31st. Now, as we all know, December is short for decimal. And of course, October is short for octal. Now, for the number people in the group, what that tells us is actually quite significant. It tells us that decimal is base 10, and the way we would record Christmas's date then is 25 with the subscript 10 to show that's our base. That tells us what the base is, and it tells us the values in each of our first two place values. Halloween, of course, is in base 8 since it's octal, and so that tells us that Halloween is in 3-1 in base 8. So let's represent Christmas first since we're most familiar with base 10. It tells us that in our ones place value we have 5 units. So I'll put down my 5 units. And again, you'll notice still this left to right, top to bottom, because we want to maintain the subtizable units. We will put down 2 of our 10 place values, and that's how we represent 25 using the base blocks. When we start looking at Halloween, we have a slightly different problem in that we've never worked with this before, but we at least know what to do with the units. We'll put the 1 unit down, and now we have to think a little bit, and what we have to think about is, what does this place value look like? Well, we have to sing a slightly different song, don't we? And the song that we will sing now is If You Can Regroup, You Must Regroup, and this is how you'll do it 8. So that tells us that the long units, rather than being 10 from end to end, will be 8. And so I'm going to put them down here. There's 3. Because of my subtizing, I know how that one works. There is 6. And 2 more, and that will make my first grouping of 8. So you'll have to bear with me a little bit while we snap these together. As I say, these are not necessarily the easiest units to snap together, but we can build any base that we like, and in fact we're doing so right now. We're building a place value we've not seen before. We're building an 8 place value. While I'm doing this, you might want to ask yourself, I wonder what the next unit up would look like. Well, let's see, we'd sing the song twice, so it would be 8 of these units. So what have we got so far? Well, let's see, we have 1, 1, and 1 grouping of 8. So I need to make 2 more groupings of 8 in order for us to get this completed. I'm going to pause a little bit here, and I will build the other 2 8s. There's no point in subjecting you to the length of time it takes me to put those together. There is our next grouping of 8. And there is our third grouping of 8. So we have now represented in their respective bases 2, 5 in base 10 and 3, 1 in base 8. Some of you might remember that there was a rather lengthy formula conversion to go between bases, but we can do it quite a bit more simply because we have the objects right here. What we will do is we will reconfigure these so that they represent base 10 rather than base 8. So in essence, we're converting the base 8 into base 10, and we're doing it with very physical actions here. We're literally taking the cubes and we're adding 2 to each 8, and when we're done, what we should have is we should have the corresponding base 10 number, and we can check that to make sure that it actually matches up. I'm going to take one of these 10s from our Christmas representation, and, well, son of a gun, look at that, it worked. There's my 10, and I look over here, and that's another 10. So what I need to do then is I need to take these leftovers, if you will, and put them into our subtizable chunks so that they look the same as what we had when we set up our Christmas representation. And sure enough, look what we have. We have 2, 5 in base 10, which is Christmas, is the same as 3, 1 in base 8. And we can see that because we've converted them into the same base of 10, and we see that they're identical. Now, that tells us from a math perspective that since these have identical representations, we can use them interchangeably. I could celebrate Christmas at Halloween. I could celebrate Christmas at Halloween or Halloween at Christmas, either one. As I say, it's not that great of a joke, but I hope you understand at this point that this notion of base conversion doesn't have to be that difficult. The secret is to remember what is the base and generate the corresponding place value. So in this case, the first place value is our 1 place value. Our second place value would be our 8 place values. If you think about it, what do you think the next place value up in base 8 would be? Well, no. It would be 8 groupings of 8. 1, 2, 3, 4, 5, 6, 7, 8. It has the same square shape, and so our next place value would be the 64s. So instead of having 1s, 10s, and 100s, in base 8 we have 1s, 8s, and 64s. We'll build on this notion further when we explore bases in general.